Well, good morning and welcome back, everybody. I appreciate it. Hopefully all our technical issues have been resolved. Hopefully everybody can hear us and see everything fine. My name is Paul Schwartz. I'll be taking the next part of the presentation, and then you'll also be hearing from Henry Chang, who will be covering some of the issues later this afternoon, talking about some of the lead-free issues. As Patrick noted during his presentation, if you have questions, please make sure you type them in and let us know, and then we'll try to answer them as we go along. We did receive one inquiry after Patrick's presentation in regards to the field test. Patrick mentioned that the assemblies have to go through a lab and one-year field test, and we do typically test those assemblies on a nominal 30-day period. So those units do get tested. The question that came in is said, would it be more directly related to the normal operation if we just tested them once a year instead of monthly? We do on some of the sites. We do have some of the field test sites where we test monthly. We do have some we do test maybe quarterly, and then some maybe every 6 months, depending on the location and the application. The problem we have, as much as it may be a closer simulation of real world, if we were to test them once a year, obviously it would be very difficult to wait 12 months to find out that a product had failed 2 months into the field test, and we didn't know it for another 10 months. So we realize that in some cases it may be beneficial, but this is where we rely on the feedback from people in the field. We want testers who are experiencing normal tests. We want administrative authorities who are recording field test data. If they're finding products that are not performing acceptably, we will investigate that. And that's really an added part of our evaluation process. It isn't once it's completed lab and field, they're forgotten. We continually need input from the personnel out there, both the testers and administrative authorities. So please, as we talk about issues throughout the day, if you have other questions, we'll try to address them, and hopefully we can help. So thank you. Well, some of the issues we wanted to talk about, specifically with repair, normally you hear from the foundation talking about the approval process as Patrick outlined. But today we wanted to talk a little bit more about some of the issues that the actual field personnel may be dealing with repair of assemblies. And some of those topics we want to deal with are, one, understanding the backflow prevention assemblies. How do they actually function? Some of the approval issues that actually may relate to what a backflow tester or a repair technician may be dealing with. Then we will get into some specific components. What are some of the components of the backflow prevention assemblies that we need to be looking at, and how do we address them? The test procedures. Those field test procedures are not just something in a book, but they are something that are going to be the direct help to any backflow tester understand exactly what's going on with that assembly. So the test procedures are not just to find out when a unit is working properly, but also to determine when it's not working properly and to help define what specific issue may be at hand. We'll then get into some of the repair and maintenance issues, some of the nightmares that some of you probably have experienced. And then finally, this afternoon, we'll be talking about some of the lead issues. Knowing that the changes in definition of lead-free have occurred in the last few years, we want to make sure you fully understand how that affects the parts and components of a backflow prevention assembly. So these are the topics that we hope to address over the next few hours. And as we go through, please, if you have questions, please send that to our folks here in our office, and then we'll try to address those as we can. So when we start dealing with assembly, repair, and lead issues, I think probably one of the things that we have found from our many years of putting on training classes is understanding the assembly. How does it actually function? It isn't just memorizing field test procedures, but do they truly understand how the assembly functions? I don't have to tell the group here. I'm sure most of you are well versed in the cross-connection control terminology and dealing with the assemblies, but keep in mind the people who are not as familiar as we are. When we start talking about what a backflow preventer is intending to do to prevent backflow, many people you talk to have no understanding of what that really is. We know backflow preventers are to prevent back siphonage, and some are also preventing back siphonage as well as back pressure. So these are some of the basic issues I think as repair personnel we need to make sure we convey to people out in the that we're dealing with. You know, what is that backflow preventer? Many times it will be a product that people truly don't understand what it is. They don't think it's needed, and they don't believe that backflow ever occurs. So that's probably one of the underlying issues we continually ask for is if you've experienced a backflow incident of any type, we would like to know about it, because these are the questions we get from the people who do not understand what the assemblies are or believe they're even necessary. Does that backflow ever occur? So please forward that information to our office whenever you think you've experienced a backflow incident or you've read something. It helps us, because some of these basic issues that we deal with every day are very, very foreign to people that we're dealing with. One of the things that our manual review committee, as Patrick outlined, we felt that the manual itself had to do a better job of explaining how the assemblies operated. I think all too many times, a lot of the training people get, they're basically memorizing field test procedures or memorizing steps, but they truly don't understand how the backflow preventers function. So one of the things that the manual review committee wanted to do was to provide more of that clarity, that information in the manual to show how does a check valve actually operate. We wanted to provide that detail to help explain to others. I think we all recognize understanding an issue is one thing, but you really know you understand it if you can explain it to somebody else. I mean, how many times you had to explain something to your own kids for any reason, understanding an issue, you truly have a better understanding of it if you can explain it to others. So this is where we found that even though we may have very proficient testers and repair technicians out there, maybe they didn't always truly understand what was occurring. So we had illustrations that were added to the 10th edition of our manual trying to explain more of the specific components. I mean, that one-way check valve, which may seem very simple in concept, again, may not be clearly understood. So we added illustrations showing how does a check valve work? What are the things holding the spring, holding it shut? How is that sealing? Are there sealing surfaces, discs, seats, etc.? So we tried again to show in a fairly simplistic form how those particular components operate. We also wanted to show different types of valves, where you may have what is considered an axial moving check, which is illustrated on the left side, as compared to a hinged or clapper type check on the right side. Again, depending on the type of backflow product, you may see a variety of styles that are being used. And so understanding how these check valves function is going to be very helpful to the person as they start to test the assembly, and more critically, when they have to provide any maintenance or repair to the assembly. So again, we wanted to provide more of that information. If you recall back when you were the newbie, when you didn't understand, you know, it took a while to understand how these backflow preventers function. So we wanted to be able to provide that information in a little more readily available context. We also found a great misunderstanding people had about how a check valve operates. In our digital world, a lot of people assumed the check valve was digital. Either it was open or it was closed. And by that, I mean fully open or fully closed. They didn't realize that it really is an analog type of product. It will open and close depending on the amount of flow going through that check. So this is one of the difficulties we've had conveying this information to field personnel because they don't understand really how that check valve may be working. So we find this has really been helpful to kind of show people that check valves will open gradually depending on flow and may never get to the fully open position unless there is a very high flow rate going through the assembly. So these are some of the illustrations that are now contained in the 10th edition of the manual to, again, to try to convey some of these concepts.